Hello class, my name is Ian Satoda and I will be doing this video on the Leidenfrost Effect. The Leidenfrost Effect was named after Johann Gottlob Leidenfrost, who was a German scientist, and he wrote about it in A Tract About Some Qualities of Common Water in 1756. So what is the Leidenfrost Effect exactly? This effect occurs when a liquid, such as water, touches a surface that is much hotter than its boiling point. For common water, the effect kicks in at about 200 to 250 degrees Celsius, and the Leidenfrost point is so varied because it depends on the surface of the metal. Compared to the boiling point of 100 degrees, the Leidenfrost makes it so water is evaporated at a much slower rate. So, why does this happen exactly? The concept is actually quite simple. When the water touches the superhot surface, the water on the bottom touches it first. Therefore, the bottom of the water droplet evaporates so fast that it creates a pocket of water vapor underneath the rest of the droplet. Therefore, less surface area of the droplet is actually touching the pan, causing less heat transfer between the pan and the water, because there is less conduction. You may have also noticed in the last video that the water moves very easily. Well, this is due to the reduced friction between the water vapor and the pan. I've demonstrated some trials of water at different temperatures. At 50 degrees, basically nothing happens. So at 100 degrees, it's easy to tell that the water bubbles up very quickly and evaporates at around 7 seconds. Here you'll see that the water bounces around a little bit, just as it will at 200 degrees. However, the 200 degree pan causes the water to actually evaporate slower at around 3 minutes, and you'll notice that the water doesn't bubble up and instantly evaporate like the previous temperatures. At 250 degrees Celsius, the same effect seems to happen. This table shows the differences in times that the water takes to evaporate with different temperature. This effect can be shown, although I do not recommend it, by dipping your hand in liquid nitrogen. It's possible to dip your hand in liquid nitrogen for a very short time and not feel the cold. In this case, your hand actually acts as the hot surface because liquid nitrogen boils at negative 195 degrees Celsius, and it creates a pocket of air between the hand and the nitrogen when it evaporates. This also explains why liquid nitrogen scuttles along the surface when poured, because normal air's temperature is so much higher than liquid nitrogen's boiling temperature. Some people have even demonstrated the Leidenfrost effect by dipping their hand in water and sticking it in molten lead. This causes the water to boil so fast that a layer of vapor protects your wet hand. I strongly recommend that you do not try this at home. Some scientists have found uses for this effect in cooling technologies such as thermostats. The Leidenfrost effect can cause water to float uphill with the slanted, heated grooves. Therefore, scientists can use this property to transfer water. This works because the water vapor underneath the droplet tries to rise and escape by pushing down on the slants, creating an upward normal force. Researchers at the University of Bath have created a Leidenfrost maze that can control the direction of the water droplets using these tiny grooves. I recommend checking out the University of Bath's and Dr. Takashina's research. It can also be used to cool computers and replace cooling fans. The Leidenfrost effect could be utilized by using the computer's chip's heat to move the water droplets. Some have even considered this effect for acetone that can self-propel itself by touching a hot water surface. This could help lower friction in systems where friction uses up too much energy. Alright, that about wraps it up. Thank you so much for making it to the end of the video.